கிளாஸ்ல நாளைக்கு வந்து நாளைக்கு எடுத்துப்போம். இந்த டெஸ்ட் இருக்கா? நாளைக்கு பண்ணிட்டு போகணும் ப்ராப்ளம். அப்போ நாளைக்கு கேட்க நாளைக்கு வந்து சால்விங் ப்ராப்ளம். I don't know about your teacher. They asked you to come. They have been doing some problems today. Get started. So let's do some problems based on each concept in this chapter. Okay, right from the beginning, whatever concepts we discussed, based on each concept, we'll try to do at least 3-4 problems. Okay, so as I told you previously, this is a very, very, very important chapter. And if you understand this right, you can solve most of the problems because it involves a lot of concepts related to vectors. We need to get that clarity. Okay. So first set of problems that we are going to deal is, it's based on the Biot-Savart, right? And for Biot-Savart law, the formula that is used is dB is equal to mu naught times ideal sine theta divided by 4 pi r square, right? So what is the unit used here? The unit used is going to be Tesla. Current I is measured in ampere and the distance r is going to be measured in terms of meter. And here mu naught by 4 pi is there. No? Mu naught by 4 pi takes the value of 10 power minus 7, or mu naught takes the value of 4 pi into 10 power minus 7. Okay. So what is the unit of it? It is going to be Tesla meter per ampere. Right. So those who are online, am I audible?
Yes, sir.
Okay.
Sir.
Right. So having said this, let's see what is the first problem. The question is, a wire placed along the north-south direction carries a current of 8 ampere from south to north. So let's look at only the first part of the question. So there is a current carrying conductor placed along the north-south direction and carries a current from south to north of how much value? It carries a current of 8 ampere. Right. Find the magnetic field due to a 1 centimeter piece of wire. So on this conductor, there is a 1 centimeter piece of wire due to which we need to calculate the field, right, at a point 200 centimeter northeast from the piece. So what is northeast direction? So this is the point P, which is at a distance of, sorry, how much is the distance? 200 centimeter. Yeah, it is at a distance of 200 centimeter. Okay. It's at a distance of 200 centimeter. Since they told northeast direction, what is the angle made by r vector with respect to the horizontal? How much is this angle? How much? 45. So it is going to be 45 degree. If this is 45, this is also going to be 45 degree, right? So we need to calculate the magnetic field due to this small piece of wire. What is the formula telling you? dB will be equal to mu naught divided by 4 pi into ideal sine theta the whole divided by r square, right? So mu naught by 4 pi has a value of 10 power minus 7 into I is how much? The current that is flowing is 8. And what is the length of the conductor which is participating? So it is 1 centimeter. So it is 10 power minus 2 meter. The whole divided by, what is r square? R is the distance from the point, sorry, R is the distance from the current carrying conductor to the point where you are measuring the field. So it is going to be 200 centimeter is basically 2 meter. 200 centimeter is 2 meter, right? So r square is 200 centimeter square or 2 meter square. So it should be 4 into sine of how much? This is where you need to be careful. Here it is 45, but I would like to stress on one point that whenever you're taking the angle is always taken between the current carrying conductor and r vector. See, suppose in a certain problem, here it is 30 and here it is 60, no, you should not take 30. So you should always take the angle between the current carrying conductor and r vector. Are you able to understand? So this angle is what we need to take. Since here it is 45, I am taking it to be 45 itself. So 4 is going to cancel this 8 2 times. So 10 power minus 7 into 10 power minus 2 is going to be 10 power minus 9. So 2 into 10 power minus 9 into sine 45 is going to be 1 by root 2. Answer will be root 2 into 10 power minus 9 Tesla. I wrote it in Tesla because we converted everything to SI unit. Is that clear? So what is the direction of it? Find the magnetic field. So they asked only the magnitude, but in this problem, is it possible for us to find the direction? So current is flowing in the upward direction. Place the thumb of your right hand in the direction of current. Curl the fingers. So on the right of it, your fingers are going and hitting the board. So since it is hitting the board at point P, it is into the plane. So here the magnetic field is going to be of value root 2 into 10 power minus 9 into the plane. Here. Understood? So root 2 is 1.4, yeah, into 10 power minus 9. It is normal and it is into the plane of the paper. Right. So let's solve this problem. This is your NCERT problem only. An element delta L is equal to delta X I cap is placed at the origin and carries a large current of 10 ampere. So there is a conductor like this. On this, at the origin, there is a piece that is considered which is of delta L, and it is going to be of the value delta X I cap. In the sense, the current is flowing in the direction of I cap. It is 10 ampere. What is the magnetic field on the y-axis at a distance of 0.5 meter? So if I take this point to be P, at a distance of 0.5 meter, that is half a meter, what is going to be the magnetic field there? So what will be right? Can we write dB is equal to mu naught I divided by 4 pi into dl sine theta, the whole divided by r square. So what is mu naught by 4 pi? It is going to be 10 power minus 7. What is the value of I? I is going to be 10 ampere into what is the value of dl? dl is going to be equal to delta x. So how much is the value of delta x? Delta x is given as 1 centimeter, or it is also going to be 0.01 meter. 10 power minus 2 meter, no? So I'll deal like that itself. I'll deal it as 10 power minus 2 itself. 10 power minus 2, the whole divided by, what is going to be the value of r square? R is the distance from the current carrying conductor to the point. How much is r? Half. So it will become 1 by 4 into what is the value of sine theta? Angle between both is 90. So sine, it is going to be sine 90. So this will be 1, right? So 4 will go to the numerator. 4 into 10 power minus 7 into 10 power minus 2 is 10 power minus 9. 10 power minus 9 into 10 is going to be 10 power minus 8 Tesla. So it is going to be 4 into 10 power minus 8 Tesla. But in this problem, it is difficult for me to say what is the direction, because they told what is the magnetic field on the y-axis at a distance of 0.5 meter. So the y-axis could have been above or below. The previous problem, it was clear. They told northeast. So that is why we were sure that it was into the plane. Here it is, it can be above or into. Suppose if it is above, then what is going to be the answer? It will be out of the plane. Because use your right hand, not left hand. Okay. So be careful. So when the current is flowing in this direction, place your thumb like this and curl your fingers. At the bottom, it is going and hitting the plane. If you are able to find the direction on one side, exactly on the other side, it will be opposite. So all that you need to check is check where your fingers are going and hitting the paper. So in this case, it is going and hitting the paper at the bottom. So here it will be into the plane. Since here it is into, above it will be out of the plane. Am I clear with this point? Did you all copy it? See, with respect to this diagram, we are correct, no? Above it is out of the plane. So that's what they gave it as plus Z direction. Okay. Now, so the next set of problems that we are going to see is based on the concept of magnetic field due to a straight current carrying conductor. And for a straight current carrying conductor of finite length, when you take a straight current carrying conductor of finite length, the magnetic field due to it is going to be mu naught I divided by 4 pi a into sine phi 1 plus sine phi 2. So just to recollect the diagram, if this is a conductor of finite length and there is a point P where you're interested to calculate the field, the distance from the current carrying conductor to point P, let me call it as A. So this A is this. A is the perpendicular distance from where? From the current carrying conductor to the point. Is that point clear? Second, phi 1 and phi 2, which are given here, phi 1 and phi 2, are the angles taken between whom? Taken between this distance and the line joining the point to the topmost point and the line joining the point to the bottommost point. So the phi 1 and phi 2 should always be considered near the point where you are calculating the field. Okay. So this is the formula. The derivation for this, we have already seen it. Right. Next is, what is the magnetic field due to an infinitely long straight current carrying conductor? That is going to be equal to mu naught I divided by 2 pi a. How much is that? It is mu naught I divided by 2 pi a. How is the conductor going to be? The conductor will be like this and the point P will be here where it is at a distance of a and the current is going to be I. So it will be mu naught I divided by 2 pi a. Okay. Where the magnetic field is measured in Tesla, current is measured in ampere, and the distance A is not alpha, and the distance A is measured in meter. Okay. So I would like to give you one more formula also here, which we have already discussed. If the point P is considered, right? If the point P is considered near one of the ends, then in this case, the magnetic field will be mu naught I divided by 4 pi a. If it is considered in between, if it is considered somewhere in the middle between the endpoints, in that case, it will be mu naught I divided by 2 pi a. So you need to remember this very clearly. So there are three formulae that we discussed. What are they? Mu naught I by 4 pi into sine phi 1 plus sine phi 2. That is for a finite length conductor. If it is of infinite length, if the point is taken in between the endpoints, if it is taken as, see, there is nothing like midpoint, but if it is taken between the ends, if it is taken in between the ends of the conductor, then the magnetic field is going to be mu naught I by 2 pi a. If the point is taken at one of the ends itself, it will be mu naught I by 4 pi a. So please be careful with the problem, right? So those who are online, are able to understand?
Yes, sir.
Shall I proceed? So let's look at this question. A current of 10 ampere is flowing east to west in a long wire kept horizontally in the east-west direction. Find the direction in horizontal plane at a distance 10 centimeter north, 20 centimeter north from the wire, and in the vertical plane at a distance of 40 centimeter downward and 40 centimeter upward. So this is a problem where you need to be very careful. Okay. So let me take this to be the table. So read the question carefully. A current of 10 ampere is flowing east to west in a long wire kept horizontally. What is the meaning of horizontally? On this table, right? On this table, there is a wire kept like this. So how is the current flowing from east to west? So with respect to you, what is east? right side is east, left side is west. Okay. So on this itself, on this plane itself, this is north, this is south. So one common mistake that happens is most of them will take this to be east and west accepted, but they take this to be north and this to be west, sorry, south. Don't do that mistake. Why is it so? Because they have clearly mentioned what is the keyword here. The keyword is horizontal. So if it is horizontal, the north and south are also on the table itself. Is that point clear? Now, what is our job? Find the magnetic field in the horizontal plane. Find the magnetic field in the horizontal plane, right? In this horizontal plane, at which distance? At a distance of 10 centimeter north, means 10 centimeter this side. Similarly, at a distance of 20 centimeter south, so 20 centimeter this side. So if I have to visualize it diagrammatically, then if I take this to be the horizontal table, right? If I take this to be the horizontal table, observe. On this, there is a conductor which is placed and the current is flowing from east to west, right? So parallel to this, let's say there is a point here which is at a distance of 10 centimeter and this is going to be north. And there is another point which is at a distance of 20 centimeters south. So let's go one by one. So what is the answer for the first one? For this conductor, since it's a long wire and this point is taken in between the endpoints, what is going to be the magnetic field? B will be equal to mu naught I divided by 2 pi A. So mu naught by 2 pi is how much? Remember, mu naught by 4 pi is 10 power minus 7. Mu naught by 2 pi will be 2 into 10 power minus 7. So 2 into 10 power minus 7 into what is the value of I? I is 10 ampere. I is 10. The whole, so mu naught by 2 pi is taken. I is substituted. A is how much? A is the distance from the current carrying conductor to the point. So how much is that? 10 centimeters. So 10 into 10 power minus 2. 10 and 10 will get cancelled. Answer will be 2 into 10 power minus 5 Tesla. But what is the direction? When they say magnetic field here, they didn't mention it as magnitude because all the points are clearly mentioned. So I'm assuming they're asking us the direction also. When the conductor is placed like this, right? Current is flowing from east to west. So you need to place your thumb like this and curl your fingers. So when you curl your fingers, I'm able to observe that my fingers are going and hitting the plane on the north side. So it is like this thumb. On the north side, it is going and hitting the plane. So at north, it is going to be into the plane. So when I say into the plane here, right, you need to be very careful, isn't it? Actually, when I say into the plane, you need to mention it as vertically downward. In this case, why is it so? Because current is flowing from east to west. My fingers are actually going in the downward direction. So current is going to be in the vertically downward direction. So what is the answer you will write? So it is going to be of this magnitude, 2 into 10 power minus 5 Tesla, but vertically downward. So it is going to be vertically downward, right? In a similar way, if you take 20 centimeter south from the wire, so if I take 20 centimeters south from the wire, if I take this point to be S and this is at a distance of 20 centimeter, then what is going to be the magnetic field in this case? Formula is the same, mu naught I divided by 2 pi A. So mu naught, everything else is going to be the same, 2 into 10 power minus 7 into current is 10 ampere divided by, only difference is here it will become 20 into 10 power minus 2. So 1 0 is gone, 2 and 2 are gone. Answer will be 10 power minus 5 Tesla. That is obvious because as distance increases, magnetic field decreases. When it was 20 centimeter, it was 2 into 10 power minus 5. At double the distance, magnetic field became half. Is the point clear? Actually, we need not calculate also because B is inversely proportional to A. Is the point clear? So in this case, what will happen is here, if the hand is going vertically downward, here it will be vertically upward. That's it. So it will be vertically upward. Shall I proceed? Right. So next question is, in this itself, we need to find what is going to be the magnetic field in the plane, in the vertical plane at a distance of 40 centimeter downward and 40 centimeter up. So again, we'll visualize it. So if you observe this, if I keep this to be the pen, okay, let me take this wire. Okay, if I keep it like this is east, west, north, south. So what is the question saying? 40 centimeter downward means with respect to this table, 40 centimeter downward, and 50 centimeter upward means it is here. Okay. So at 40 centimeter downward, observe what is going to happen. The current direction is fixed. It is flowing from east to west. So your finger is fixed like this. But at the bottom, right, at the bottom, what is happening is when you curl your fingers, at the bottom, see, your fingers are coming in this direction. So this direction is basically south direction. According to this problem, the south is here. So anything parallel to that will also be south. So if you take a point 40 centimeter downward, the direction of magnetic field is going to be southward. So on the other side, it should be northward. Right? It should be in the north direction. Is that point clear? So let's take this. This is east. This is west. Okay. So I just want to repeat it again. I want you all to observe it carefully. So this is east, this is west. Okay. Current is flowing from east to west. So when it is flowing from east to west, I'll keep it here. Okay. When it is flowing from east to west, when I curl my fingers at the bottom, it is coming in this direction. At the bottom, it is coming in this direction. So according to this problem, east, west, north, south. So what is this direction? South. Right. So if I take a point 40 centimeter downward, if I take it 40 centimeter downward, what is going to be the direction of magnetic field? Direction of magnetic field will be in the south. But what is going to be the magnitude? Magnitude part is very simple. So B3 is going to be equal to how much? Mu naught I divided by 2 pi A. So what should happen? You people tell me. When it was at a distance of 10 centimeter, it was 2 into 10 power minus 5. When it went to 20, when it became double, it came to 4 into, sorry, it came to 10 power minus. So here what should happen? It should become half of this, or let's take this as reference. It will become 1/4 of this value. 1/4, what is the expected answer? 0.5. No, let's see if we are getting it. So mu naught I by 2 pi A is going to be 2 into 10 power minus 7 into I is going to be 10, the whole divided by what is the distance? A. So 40 into 10 power minus 2. Cancel this and this, it will be 2. So 1 by 2 into 10 power minus 5. It's the same. It should work. That also you can do. Or you can see, since everywhere you wrote it as in terms of 10 power minus 5, leave it as it is. Why are you worried about it? So you can write 0.5 into 10 power minus 5 Tesla in which direction? In the south direction. Similarly, at the topmost point, what is going to happen? B4 is going to be equal to mu naught I divided by 2 pi A. So that is going to be 2 into 10 power minus 7 into 10, the whole divided by what is A? 50 centimeter upward. So it is going to be 50 into 10 power minus 4. So 0 and 0 will get cancelled. 5 will cancel this to 0.4 times. So it will be 0.4 into 10 power, for this minus 2, sorry. This 10 power minus 2 because it's centimeter, no? So 0.4 into 10 power minus 5 Tesla. In which direction is it going to be? It will be in the north. Clear? This is actually a textbook problem. There's an NCRT one. I hope you could visualize it, right? Shall I proceed? Both are same. You can try this problem. What is that? Did you see the pen? Yeah. So what is the answer for this? 8. Okay. So in this problem, there is a long straight wire carrying a current of 30 ampere is placed in an external uniform magnetic field. So it's placed in an external uniform magnetic field of how much value? 4 into 10 power minus 4 Tesla, which is parallel to the current. Find the magnitude of the resultant magnetic field at a distance 2 centimeter away from the wire. So long straight wire carrying a current of this placed in. So what they are trying to say is there is a current carrying conductor, right? There is a current carrying conductor which is placed in external magnetic field of how much value? 4 into 10 power minus 4 Tesla. Please be careful with this. There is a magnetic field existing here already due to some other conductor of how much value? 4 into 10 power minus 4 Tesla. Is that point here? Now the second part is find the magnitude of resultant magnetic field at a distance of 2 centimeter away from the wire. So there is a point P here, which is 2 centimeters. So 2 into 10 power minus 2 meter, there is a point P that is lying. We need to calculate the resultant magnetic field. So observe, if the magnetic field is parallel to the current carrying conductor at point P also, it is going to have the same value of 4 into 10 power minus 4 Tesla. Accepted, right? So one common mistake is, if you find the magnetic field due to this current carrying conductor as, you write it as mu naught I divided by 4 pi A, and you leave it as 10 power minus 7, mu naught by 4 pi is 10 power minus 7 into 30 divided by, what is A? The distance, 2 centimeter, no, 2 into 10 power minus 2 meters. So this will cancel 15 times. If you leave the answer as 15 into 10 power minus 5 Tesla, you're wrong. Because this 15 into 10 power minus 5 Tesla is generated due to the current carrying conductor. And in what direction is it going to be? In this case, at least, see, since they didn't mention anything, there is a rough diagram of my assumption, right? In this case, the magnetic field is going to be into the plane. Accepted? Because if this is the direction of current, my finger is placed in the direction of current, curl the fingers, it is going and hitting the plane. So it is into the plane. Observe. So one magnetic field is into the plane, one magnetic field is upward, right? One magnetic field is into the plane, one magnetic field is upward. So when you go to the other side and see, it look like this. So there will be a resultant magnetic field for this 4 and 15. In which direction? Somewhere in the diagonal. By applying the parallelogram law of vectors, you will be able to find what is the resultant. So that is why the question is very clear. You need to find the resultant magnetic field. So if I take this value to be B1, and I take this to be B2, then what is going to be the resultant magnetic field? It will be the root of B1 square plus B2 square. According to parallelogram law, you will have A square plus B square plus 2AB cos theta. But A square plus B square plus what is the angle between B1 and B2? It is 90. Cos 90 is 0. That is why I didn't write it. Right? This is 15. That is 4 into 10 power minus 4. So can I write this as 1.5 into 10 power minus 4 Tesla? Can I write it like that? So that I can take the 10 power minus 4 common outside. So all that I need to do here is square root of 1.5 square, that is 9 by 4. Why did I write 9 by 4? Because 1.5 is 3 by 2. So 3 by 2, the whole square is 9 by 4 plus 4 square, that is 16 into how much is the value? 10 power minus 4. Actually, inside you will have 10 power minus 4, the whole square. That will come out as 10 power minus 4. So root of 9 by 4 plus 16. So 64 plus 9 is what you're going to get. Right? When you take LCM, you will get 64 plus 9. 64 plus 9 is 73. Right? So you will get root 73 divided by square root of 4 will be 2 into 10 power minus 4 Tesla. So this will be the resultant magnetic. Did you understand or not? Right? So you can expect these kind of questions also where they ask you to find the resultant values. Those who are online, I hope you could understand.
Yes, sir.
Yes, sir.
You want to put that up? Okay. Put it up. Hello. Who வெளியில இருக்கு உள்ள இருக்கு. Correct. Into 10 power minus 4. This value is very high. Clear? So let's check the solution for this. Shall we? But how come they got 5? Can I tell you what is the mistake I made? I applied the formula wrong. I went inside and came, no. Wherever you I wrote 4. It's 2, no. I gave you 3 formula in the beginning. Epa 2 varum. When it is in between, no. 4 pi a will come when it is taken at one of the ends. That is why I was wondering, yeah, why I got this doubt is, see, the previous problem we had 20. So something closer. Guys, are you able to understand what is the mistake? All that you have to do is change this as 2. That's it. 2 change panna, then you will get this as 3 into 10 power minus 2. 3 in 1, you need not do this much. Actually, I'll do this problem again. Not completely. I'll do it from here. So just to avoid confusion. So listen. So we understood that the magnetic field due to the magnetic field already existing is going to be called as B1, right? And let's say that the magnetic field produced due to this current carrying conductor is B2 and its value is going to be mu naught I divided by 2 pi A. So what is mu naught by 2 pi? It is going to be 2 into 10 power minus 7 into what is the value of I? I is 30. So 30 divided by what is the distance? It is 2 into 10 power minus 2. 2 and 2 will get cancelled. Answer will be 30 into 10 power minus 5, or it is going to be 3 into 10 power minus 4 Tesla. Now, since we know that B1 is upward and B2 is inward, when you try to look at it like this, then the resultant magnetic field is going to be equal to root of B1 square plus B2 square according to the parallelogram law of vectors. So what will you get? 3, 4 and 5 are Pythagorean triplets. So you will get 5 into 10 power minus 4. Right? 3, 4 and 5. So this is the answer. right? So we can try out one last problem. Okay, I want you to do it. Do this. Treat them as individual points, calculate the magnetic field at each point, and then apply the right hand thumb rule. That will be the answer. So what is the answer? For point P, what is the answer? Two into 10 power minus 7 into 20 divided by 10. So you get 4 into 10 power minus 5. 6. No, they ask for point PQR individually, no? Oh, there are two wires. Yeah. Due to the first wire, how much is it? 4 into 10 power minus 5. So 4 into 10 power minus 5 out of the plane. Okay. Due to the second conductor, 3, no? 2. Oh, denominator is changing. Yeah, correct. So numerator you will have 30, denominator also you will have 30 cancel. So you'll have 2 into 10 power minus 5. This is into the plane. So there it was 4 into 10 power minus 5. Here it was 2 into 10 power minus 5. So resultant will be 2 into 10 power minus 5 out of the plane. 2 into 10 power minus 5 out of the plane. How many of you got the answer? So let's do it quickly. Observe. So we have two conductors, one of 20 ampere and 30 ampere, which are carrying the currents in the opposite direction. Our job is to find the value of magnetic field at point P, Q, and R. Right. So let's take point P at the first place. So if I take point P, right, if I take it as point P, if I call this as first conductor, this as second conductor, right? So what is going to be the magnetic field due to the first conductor? It will be mu naught I divided by 2 pi A. So I dash, or I'll call it as I1 A1. That will be I1 A1. What is the, so this value is going to be 2 into 10 power minus 7 into what is the value of I1? 20 divided by what is the distance? 10. 10 into 10 power minus 2. So this will cancel this twice. Answer will be 4 into 10 power minus 5 Tesla. But in which direction? So if you take the current carrying conductor due to this 20 ampere, on the right hand side it is into the plane, on the left hand side it will be out of the plane. So you put a dot and a circle around it. That's it. Right. So similarly, the magnetic field due to the second conductor will be mu naught I2 divided by 2 pi A2. So it will be 2 into 10 power minus 7 into, it is going to be 30, the whole divided by A2 is how much? 10, 10, 10, 30. So 30 into 10 power minus 2. So 30 and 30 will get cancelled. Answer will be 2 into 10 power minus 5. Here, if you observe, the current is downward. So it will be into the plane. So here it is into the plane. So what will be the net magnetic field? BR will be equal to 4 into 10 power minus 5 outside, 2 into 10 power minus 5 inside. Outside, if you take to be positive, inside as negative, resultant will be 2 into 10 power minus 5 outward. Is the point clear? Second. So if you look at the second case, if I take Q, at point Q, magnetic field due to the first conductor will be mu naught I1 divided by 2 pi A1. So how much is that going to be? 2 into 10 power minus 7 into, what is the value of I1? 20, the whole divided by, what is going to be the distance? 10 into 10 power minus 2. So answer will be the same. How much is it? 4 into, answer will be the same. 4 into 10 power minus 5, but this time it will be into the plane. Right. Similarly, if I calculate the magnetic field due to the second conductor, it will be mu naught I2 divided by 2 pi A2. So this will be 2 into 10 power minus 7 into I2 is how much? I2 is 30, the whole divided by distance is again 10. So 10 into 10 power minus 2. This will cancel this 3 times. So it will be 6 into 10 power minus 5, but this time it will be same into the plane. It is into the plane because with respect to this conductor, it is still on the left hand side. So what is going to be the resultant magnetic field? It will be 10 into 10 power minus 5 or 10 power minus 4 Tesla. So it will be 10 power minus 4 Tesla. Similarly, if you take the point R, due to the first conductor, what will be the answer? So B1 will be equal to, I'm not writing the formula. So mu naught by 2 pi is 2 into 10 power minus 7 into, this distance is how much? At point R, 10, 10, 10, 30. So it is going to be, oh no, first of all, current is 20 divided by distance is 30 into 10 power minus 2. So 0 and 0 are gone. You will get 4 by 3. So 4 by 3 into 10 power minus 5 into the plane because it is the right of that conductor. What about B2? B2 will be 2 into 10 power minus 7 into 30 into 30, the whole divided by 10 into 10 power minus 2. So answer will be 2 into 10 power minus 5, but it is going to be 6 into 10 power minus 5. It will be, so here it will be, yeah, 6 into 10 power minus 5, and it will be out of the plane. So what will be the resultant? If you take out of the plane to be positive, so out of the plane is positive, then resultant will be 6 minus 4 by 3 into 10 power minus 5 Tesla, which is going to be 18 minus 4 by 3, which is 14 by 3 into 10 power minus 5 Tesla. 14 by 3 into 10 power minus 5 Tesla with a dot and a circle around it. Means it's going to be outward. Right? So this is how it is going to work. So done with this, right? So that's it for today. Next class we'll solve a few more problems based on other concepts. So revise the concepts and those are online. I hope you appear. Those are online. I hope you appear. No? Can someone respond, please? Divya? Did you all understand?
Yes, sir.
Okay. So we'll wind up. I'll see you in the next class.